There's a road enterprise that connects it.
That's right.
That's what street secret is.
I did.
That's why it's close to everything.
I think
That's close to
I'm
my
not
house.
sure exactly what
You say because he lives in the apartments?
but somehow I suspect
He lives on a train.
I've never done this very well.
I have no idea what. Yeah, I recharged it. What I did, I let it drain all the way, and then I let it recharge.
I had vitamins, tablets.
This morning,
I have vitamins.
100 watts.
I'm like, it's about like 5 days worth.
You know that
It kept the light
he's right across the street.
Really.
Yeah. I was impressed. So I'm convinced the battery is not bad. Yes.
But there's living losers from another area.
Yes. And I'm using is when I first did it, it does a self-timer. After 10 seconds.
So you're a picky eater? My friend, Mitchell, he only eats 5 burgers, fries, ketchup, pasta with no sauce or butter. He eats pizza, but he takes off the cheese.
And this one of the things I had before was that during that
He
time,
takes off the cheese. I'm like, excuse me? And then he like throws the cheese like back onto like the places where there's like the other slices of pizza. I'm like, excuse me, throw away your undesirable cheese.
and then there's after
Who throws away
8
the
seconds,
cheese?
there's another
I had a friend who
which it restores
was
power
like, you know, I don't like this sauce.
battery.
He didn't like the cheese.
Do you like pesto sauce?
And so when you order pizza,
I turned on
just put all the sauces
the switch to turn on
pizza on this side, but put all the cheese on this side.
No, it's not.
So got that.
That's good. Do you like sauce on your pasta? I don't like tomatoes. But I like sauce. Do you like ketchup?
The best thing to
Oh, are you talking about cheese french fries and dipping it in? Dude, last night, so I had it in and out. So they tried to make me feel better because I like threw up. So they brought me delicious food. I know. What is it? It's a burger.
Going to be on YouTube later on this afternoon.
Okay.
And the microphone is there.
Steak fries?
So the idea is that you should probably talk here so that it won't interfere with the projector.
Okay.
And by the way, you have 45 minutes. You'll start pointing to my wrist.
Okay.
You always have a break. Keep forgetting that. Yes, it's all break. But I can recall looking forward to spring break. Well, I think we all do. It's a break from the teachers and the students. Yes.
They have like sauces over on your It's pretty intense. They have anything like sauce.
This is the little microphone.
No, she will be talking next because otherwise nobody would be able to see.
She's standing in front of the screen.
I was advised to always check myself in the mirror before giving a talk, but maybe you can just tell Dave.
Oh, you're okay.
Okay. And that will save me a trip.
You should put your laptop over there so that you won't interfere with it.
Okay. I might play a little video.
There's a plug. Do you need a plug?
I can
Probably
probably
needs a plug.
I can probably go with that one. Okay, it says plenty of time.
Okay, I was going to put it in if you need to.
I think so.
Part of
Yeah, I'll skip that.
Skip it.
Yeah. Oops. This is some student code, and it's not very good fast.
a little like almost less.
Well, good afternoon, ladies and gentlemen. Next week, you're welcome to come in and sit, but there won't be a colloquium because it's spring recess.
This place actually open next week.
I have no idea, but so next week, no colloquium. The week after that, we will be hosting Jason Schenkel, who will be giving the nth iteration of the same talk he's been giving for the past 10 years on something to do with scripting computer games. So that's the week after next. Today I have the honor and the pleasure of introducing you to Dr. Ellen Spertus, who is on the faculty of Computer Science in Mills College. And she will explain to us how we can save the world by writing the right app. Let's welcome our speaker.
Thank you. It's good to be back at Sonoma State. In addition to teaching at Mills, I'm also a research scientist at Google down in Mountain View. So it's common to see articles that talk about how smartphone apps are transforming our lives. And if you read the articles, they talk about you can find out what song you're listening to on the radio, or you can find out the nearest place where you can buy medicinal marijuana. And I really disagree with the premise that these are transforming our lives. They're making some things more convenient, but they're not transforming our lives. But there is a part of the world where mobile phones really are, and that's in the developing world. So I'm going to talk about information and communication technology, which is a buzzword. You can watch out for this acronym that refers to information technology, refers to computers generally, and communication technology ranges from landlines to mobile phones, smartphones, the internet, Skype, and these can be really enabling technologies. In the developing world, landlines aren't common. This graph shows basically no growth in landlines from 2006 to 2011. But during the same period, the rise in mobile phone subscriptions has been huge. And this axis is in millions. So what you see at the top is 4.5 billion mobile phone subscriptions in the developing world. That's a large portion of the world population. And mobile broadband subscriptions are also growing. I'll leave a copy of my slides. The sources are listed in the notes fields. So what are people doing with those mobile phones, and how are they transforming lives? Well, this is probably the most exciting graph I've seen in my career. It's about the difference that a single mobile phone makes to the earnings of the people who can use it. That in the poorest countries, the ones with the lowest gross national product, the single phone can add $12,000 worth of wealth. And that was so astonishing to me that I tracked down the data that this was based on. And what it's about is someone living in a village, this is remote villagers, instead of traveling to a city hoping to find a job, they can find out where the jobs are and only go when they're available. Or if they own a small store, they can telephone suppliers and get items to sell in their store. Or if someone's sick, they can get medical advice. Or if they have relatives who've gone into the city or overseas, they can find out when a remittance has been sent to them, when money has been sent to them, and they can pick it up. Or they can find out what port has the best price for whatever fish they caught that day. So this is somewhere where phones are really transforming people's lives and changing them from existing in poor health and poverty to having a better life for themselves and their families. This slide is from a talk by Iqbal Qadir. I don't know if I'm afraid I'm not sure I'm pronouncing his name correctly. He grew up in East Pakistan, which is now known as Bangladesh, at a time of war and floods that killed millions of people, including his father. And he came to the United States on a scholarship to Swarthmore, and then he went to Wharton, where he got a master's degree and a PhD, and he went on to work for the World Bank and then private banks. And one day, the computer networks were down. This was in the 90s. And he and the people who usually did business with just weren't able to function, weren't able to communicate with each other. And it reminded him of when he was a teen and his younger brother was sick, and his mother asked him to walk to a village 10 miles away to get medicine. So he spent all morning walking, and he got to that village, and the medicine man wasn't there. So he had to walk home, spend the afternoon walking home. Didn't accomplish anything that day. And he realized that the two situations were the same, that communication is productivity. And think of the loss of time he had and multiply it by the hundreds of millions of people in Bangladesh, and you get a waste of resources that developing countries can't afford. So he started, he wanted to bring phones to rural Bangladesh, and he started Grameen Phone as a project of Grameen Bank, which you may have heard of. Its founder, Muhammad Yunus, won the Nobel Peace Prize for his work bringing microcredit to the developing world, especially Bangladesh. It spread to other countries and transforming people's lives by giving them access to credit. And Grameen Phone built on that. It wasn't a charity. Grameen arranged for rural phone ladies to borrow money for the phones, and the women were able to start successful businesses charging people to use these phones. And it was profitable for these women and, of course, had enormous benefits for the villagers. So this is an example of mobile phones really transforming people's lives. And here's a picture of someone using frontline SMS. I mentioned that most of the mobile subscribers do not have broadband subscriptions. Most of them don't have smartphones either, but they do have phones that have SMS. And Frontline SMS is an open source nonprofit project that connects mobile phones to computers, so that by sending an SMS, it can be handled by an internet service that can then go and send many other SMSs, can get information from the internet and send it back to you. And all sorts of wonderful systems have been built on top of it. So this is a slide about their Medic product, where instead of taking a 40-mile walk to let a healthcare professional know about a problem and receive emergency care, you can get help by phone, by the internet. Patients can give updates to their caregivers, find out about medicine available to them, treatment. Another project sponsored by Chromene is the Mobile Technology for Community Health. And I'm going to show a short video about that.
When you have a maternal death, it is really crucifying the whole family, the whole community, and the whole nation. And therefore, government has made it a national emergency to tackle maternal health and neonatal health. MDGs 4, reducing child mortality, and MDG 5, improving maternal health, are really two key challenges to us in the health sector.
The need and desire to access health information is universal. Imagine a pregnant woman experiencing pains, or a parent with a child who has a high fever. In developed countries, information is often readily available through the internet, and expert advice is a phone call or a short car ride away. For poor individuals in less developed countries, the situation is quite different, such as here in the Upper East region of Ghana. In rural areas such as this, health facilities are the only source of reliable expert advice. Local myths are prevalent, some of which can be damaging to mothers and children during pregnancy.
The myth here is that when you just start labor and you come to the health facility early, it means that you are a coward and you fear pain, and so they don't come early. By the time they get to the health facility, it might be too late.
Transport is scarce and unaffordable in these areas. Road networks are poor, so health facilities may be a long walk from home through the baking heat. Basic services may be scarce here, but the simple mobile phone is increasing in abundance. Mobile phone ownership is growing rapidly in even the most remote communities. The Mobile Technology for Community Health project, known as MOTEC, is aiming to create a world in which these mobile phones enable poor individuals to access health information that is reliable, affordable, and relevant to their lives. By designing technology solutions together with users and communities, MOTEC has been able to ensure that its services are accessible, easy to use, and tailored to client-specific needs. MOTEC has created a service called Mobile Midwife. The service sends people information on their mobile phones. Content for Mobile Midwife was based on pregnancy and child health materials from Baby Center, an online parenting resource. This was then localized for the Ghanaian context by MOTEC.
When a client registers with MOTEC, he or she gives us the date of birth of their child or the date of expected delivery of the pregnancy. With this information at hand, MOTEC would regularly give them information that is specific to the age of the child or the age of the pregnancy. Illiteracy is a challenge in our community, so clients can choose to receive their messages in audio recordings in local languages or as SMS.
Na tansi bempati ijawe baba lwa yan toto ayena boise na jiku kuto kwen kuwa ko dambu by a way, could attach the Kudona was down by paper, when you about with Tarabel, but would it tell you about hospitals about nice dinner, but over way.
1 week before an antenatal appointment, Multech sends a message to the patient to remind them to go to the health facility. If a patient misses the appointment, they receive an alert to urge them to go to the health facility soon. Meanwhile, similar information is provided to the nurses. Every Monday morning, they receive text messages listing patients who are overdue for certain care. By reminding both nurse and patient about the appointment, Multech aims to increase the quality of healthcare provided. Multech is currently being piloted in one district in the Upper East region of Ghana. A rigorous social impact assessment will measure the effects of the program and health outcomes. We believe that as Multech continues to empower women, healthcare workers, and communities with critical health information, over time, it will demonstrate its great potential for improving the health of mothers and babies, not only in Ghana, but all around the world.
So that video is from the start of the project. There's more recent ones that are longer that talk about the successes that they've had. Oop. Oop. I lose my presentation. I'll reopen that. And another project I read about was Project Surya to reduce the amount of black carbon. That's a pollutant that comes from soot, and they're working to replace the types of stoves that are used in Indian villages, that are used inside houses and cause a lot of air problems. And they're using phones to gather data for evaluation and for climate studies. The phones can detect location, they can detect heat, and using the camera, the users can take pictures of filters next to a color calibration card in order to measure the amount of pollution, and the residents can do additional measurements. So this is something else that's facilitated by phones that aren't full-fledged smartphones, but do have the ability to take pictures and send them. So if I haven't convinced you now that mobile phone apps and technology are improving people's lives, I'm probably not going to. Instead, I'll move on and talk about how you can create apps. I'm part of the App Inventor for Android team, which began at Google and is moving to MIT and other institutions. And what we wanted to do was to, our motivation in creating something to make it easy for people to create mobile apps was twofold. Part of our motivation was the declining interest in computer science, which I'm sure your faculty is familiar with, that there was a peak during the internet boom and just after that, but then interest in computer science went way down. And we didn't understand why that was the case because we think computer science is really exciting and empowering. Probably you agree because you're in a computer science department, but we wanted to bring that excitement to more people. A lot of computer science curriculum hasn't changed much since the old days and is centered around desktop computers, which is now what today's students are most excited about. Another motivation was making it so people around the world, not just American students, could create apps. But I think the press misses the point when they write about Android. It's always is Google versus Apple, iPhone versus Android phones. But that's not what Android is about. Android is an open source operating system. That means anybody can create an Android phone and they don't have to pay a cent for the operating system. And that's just not the case with iOS. Apple even wouldn't let you build your own phone for any amount of money. And other operating systems like BlackBerry, Symbian, Windows, those can be licensed. But this is something that can drop the price of smartphones, drop it to the hardware and the carrier costs. So for me, what was exciting was that people around the world might have needs for apps that weren't being met by current developers. And maybe it's even a small need. Maybe it's one that only hundreds or thousands of people have, not enough to create a commercial app. But what if people could create apps for themselves? So I think those were the two major motives for the team, computer science education and increasing the number of people who could create apps even if they don't go on to study computer science. The genealogy of the project goes way back. A grandfather of it was Seymour Papert. He studied, before becoming MIT professor, he studied with Jean Piaget, the psychologist, about children's learning and epistemology. After graduating and becoming a professor at MIT, he created Logo and was involved in inspiration in creating Lego Mindstorms, which also came out of the MIT Media Lab. Hal Abelson, back in the early 70s, was a graduate student at MIT, and he went into classrooms with Seymour Papert to see how students were using Logo. Hal has since been known for his contributions to computer science education. Here's a book on teaching geometry using Logo, and there's the book he co-authored with Jerry Sussman and Julie Sussman. He supervised Mitch Resnick, who created Star Logo, and then became a professor at the Media Lab and created Scratch. Another descendant of Star Logo was created by Eric Klopfer at MIT, Star Logo The Next Generation, and working with him, Rika Rose Roque refactored the Star Logo code to bring the blocks language into a separate library that could be used on other projects. And indeed, it's used on App Inventor. And App Inventor is a cloud service. There's App Inventor services that people connect with in a web browser that let them create apps that they can run on an emulator running on their computer or on a connected Android phone. And I will now show you App Inventor. We'll create some programs. So, in case I wasn't able to connect, I had some screenshots. This is a game I created where you have a ladybug that needs to catch an aphid, eat aphids, and avoid the frog while power goes down. And that's a picture of my little girl. Okay, so let's... Here's where I'm going to need some help. Can someone enter any user ID and password for me? I hope this isn't live streaming to YouTube. But just in case, I didn't ask anyone to shout out a password to me. Okay. Use App Inventor. Okay, so has anyone created a mobile phone app? Okay, well, what platform did you use? Android, the Java SDK? Anyone use any other platforms? Yeah?
iOS.
iOS, yeah. Yeah, Objective-C? Okay, so let me show you how to create an app with App Inventor. Instead of Hello Per, we have one called, Hello World, we have Hello Per. We want to use media. So I am going to start the blocks editor opening.
This is all through the browser?
This is all through the browser and JNLP, Java Web Start. So here's the browser part. In this, the screen is a little shrunk because I'm projecting. But for this application, what I want to do is make it have a picture of the cat. And if you pet the cat, I want it to meow and to purr. So you can use an emulator. There's a free emulator that comes with it. I'm trying to decide whether to use the emulator or the phone. I think I'll use the phone. And in the web browser, you create the user interface. I'm going to create a button, so I drag on this button, and I can set properties of the button. I want the button to look like a cat, so I'm going to get rid of the text on the button, and I'm going to put an image there. I happen to have a picture of Hal's cat, Morris. So I'll upload that. So I have a button component. And I'm also going to want there to be a sound component. Components are kind of like objects in object-oriented languages. They're GUI elements or interfaces to phone technology. So for sound, I'll find that under media. I'll drag in the sound component. And I'm going to set the source of the sound to an MP3 file I have, meow.mp3. And maybe I better put some instructions here. So for the text, I'll do pet the kitty. Okay, let's see. How can I make that more readable? Any ideas?
Make it bigger.
Okay, so make it bigger. Let's see. Font size. I'd change that here. And maybe change the color. That's not as good a color as I thought. Any suggestions what color I should use? Okay, I'll try white. Yeah, that's better. Okay, and so here we create the components. We can give them better names. We can set their properties. But where we do the programming is over here in the blocks editor, which is a Java Web Start process. And we can do this live. No available devices. Okay, maybe if I unlock my phone and connect to device.
So this is a separate application right here, this program?
It is. So that part's a little bit awkward, and we're working on improving that, making it integrated in the browser. But the library that Rika Rose created was in Java, so this is how we integrated it. Okay, so if we go to My Blocks, we see there's a button. That's the button we created. And if we want to use good abstraction, maybe we should rename it. So this button select that, and we'll rename it Kitty. And then we go over here and we choose Kitty, and we select an event. When somebody clicks on the kitty, we want to do something. What do we want to do when someone clicks on the kitty? Play the sound. So what do you think I click on here? Yeah, sound. And what method do you think I'll do? Yeah, sound play. Okay, so we have that. And, well, it looks like a button's getting squashed there. Okay, it's launching the emulator. While this is loading up, I'll show you some of the other components there are. You can play videos.
So this allows us to make an app without having to know code.
That's right. So no semicolons, no braces. It's the App Inventor block language. So you can have buttons, timers, boxes, video, animation. You can have balls and sprites bouncing on the screen. You can have it access the data on the phone. You can pick email from your phone's contact list. You can have it make a phone call. You can have it send a text message, post a tweet, take advantage of the accelerometer sensor. So for my ladybug game, you tilt the phone, and that moves the ladybug on it. Also make it so location sensor, so it knows where you're located. You can make it control Lego Mindstorms. And you can make it speak or recognize speech or use Bluetooth or scan barcodes or catch something from the web. And then there's some experimental ones, like a sound recorder created by a former member of They Might Be Giants, who now works at Google. Okay, so here the emulator popped up, and we can connect this to the emulator.
What version of Android is the emulator running?
That's a good question. I don't know which one it defaults to. I think App Inventor works with everything down to 1.6. which is probably Donut. In some cases, we write different code. We have some ifs checking what version is on it. So here you have the phone, and you can see what your program looks like exactly as you add elements to it and as you add behavior to this. So if I pet this, let's see, but there was one more thing I said it should do besides meow. What should it do? Purr. And the phone can do that. So any guesses what I want from here?
Vibrate.
Vibrate, yeah. So we click the vibrate block in. You can hear the little click. And then from built in, we can choose math and take a number and maybe make it 500 milliseconds, half a second. So then when you pet the kitty, it doesn't work on the emulator, but on the phone, that would make it vibrate. So any suggestions of things that maybe we should add to this? Yeah?
I have more of a question. Is there a way that you can view the code that this generates if you want to learn what goes on behind the scenes if you're trying to learn programs?
That is a frequently asked question. People ask a lot, how can I see the Java that this generates? And this doesn't generate Java. What we used, any guesses what we used for what a bunch of crazy ex-MIT people would use as their intermediate language? Scheme, a dialect of Lisp. There's a project called Kawa that compiles Scheme to Java bytecode. So we convert the blocks into Scheme and then use Kawa compiler, and we have a library. There's also libraries written in Java for interfacing with the components. And we made those libraries available, open source, before we even made the rest available. So that once you're used to working with the App Inventor components and you're used to calling the, waiting for the click event and calling the play and vibrate method, you can do those from your Java programs. But this doesn't directly generate code. That's very useful. The concepts, of course, all carry over. There's lists and there's control structures. You can have for loops. You can generate random numbers. And if we didn't put in your favorite language feature component, you can add it. So let me pull up some more apps. I'm going to log in with a different account that I have more apps with. You know what? I'll just switch browsers. Any other questions while I'm doing that? In back.
How did you know that the vibrate went with the sound?
Yeah, that's somewhere that's not really intuitive. You'd have to go to the documentation. Sound is vibrations, but where do you think would be a better place to put that?
Phone?
Yeah, there's a phone call component, but it's kind of all phone.
Bring up the three components that you had. You had button, you had sound, and you had something else.
Screen.
Screen.
Did you one called feedback?
Well, these are all good ideas. Okay, so do I have the... Okay, so here are some other applications. Yeah, you're right. Sound isn't the obvious place. You asked what other things we had. So under basic, here's what we have. And here, under media, there's camera, image picker, player, sound, video player. Yeah, for some things, it's hard to figure out categories. Here we have a xylophone app. And any ideas how we might have implemented that? Yeah, that we could have 8 different buttons, each of which plays one of 8 different sounds. Although instead, we just have one sound component and we change its source, depending on which note someone presses. And you might think that's cute but pretty trivial. But what this can also do is it can replay sounds. You can have it record something, and it builds it up into a list, both the notes and the amount of time between them, and plays them back. Yeah, you can create a song. So here it's connecting to the emulator I started. While it's connecting, you can see the code. You can create procedures. Here's one to play note. This takes an argument. It sets the source of the sound to the number 3 plus dot wave. We uploaded 8 wave files. Adds it to a list, adds the current time to the list, and plays the note. And then later on, when you replay it...
So all these parallel things are happening at the same time, and then underneath it, sequential what's next.
Well, yeah, since they're single processor, only one thing happens at a time, but the user doesn't have to worry about that. The user writes handlers for the buttons, and the right thing happens. So you can write non-trivial apps, and there's a lot in the App Store, and I haven't a number have been put in the App Store, the Android market, and I haven't even gone to the Advanced tab, which has some things we're really excited about. Getting back to my slides and not going over time. So I like games, so I also made a few versions of Whack-A-Mole. Here's some code. This gives you an idea for it. We have event handlers and procedures, and this uses random integers to decide where the mole should move. So has it worked? Has it interested children in computing? Yes. There's a program, Iridescent Technovation Challenge, that teaches girls from underrepresented groups technology and entrepreneurship. It's being used for the second year there. Some students at Trinity College creating an application that won a White House contest on apps for healthy eating. This is the White House CTO, and there's Secretary of Commerce, Farms, Tom Vilsack, who you may recognize from The Daily Show. If you've heard of Youth Radio, which you can hear on NPR, they started the Mobile Action Lab, and they created an app, All Day Play, which is in the Android market. An organization, Youth App Lab, in Washington, D.C., has also used App Inventor. In the first year, they involved 25 middle and high school students in Washington, D.C. 80% of the students hadn't even known what programming was, and they created more than 30 apps, 4 of which are in the market, and they started an app development company, and 4 decided to major and minor in CS. So if you want to try it out, Google released it as open source. Anybody can run an App Inventor server, but MIT is hosting one. You can go to appinventor.mit.edu. That's the server I was using. We wrote a book about it. Other people wrote other books. Don't buy it. It's available for free online now. And if you want to look at the code and add components to it, it's available online. Google Code. Yeah, there are apps on the market.
What's your name? Your group's name?
Oh, it would have the name of whoever created it. People don't always say App Inventor, but if you search for App Space Inventor, they might have mentioned that it was created with it, but they don't have to. You own entirely what you create. And if you want to get paid for working on it or another great project, the call's gone out for students for the Google Summer of Code program, where Google will pay you to work on an open source project. The MIT Center for Mobile Learning, which runs MIT App Inventor, is just one of over 100 organizations. There's a bunch of other nonprofits that you can do work for, get mentored and paid. It's great to have on your resume, and it wouldn't surprise me if your professors would give you independent study or internship credit for it. So just use your favorite search engine to find Google Summer of Code. Okay, I'll now take any questions. Yes?
This isn't I don't know how to phrase this in the form of a question, but is there anything you can say about getting the finished product out of App Inventor and into the market in a way that's most beneficial to the designer of the program?
Well, you can create an APK, an Android application package. There's a third-party app marketizer that's free, or not an app, a program, and you give it an App Inventor APK, and it creates an APK that you can upload to the market. It'll soon be added to the main App Inventor, but just create an app and run it through that and upload it. They're There isn't anything special. And there's user groups where people discuss App Inventor and how to do different things in it and what their experience has been putting things on the market. Yeah.
If you write your own app, could you use App Inventor to make sure that it's sort of meeting standards, so to speak?
In what way?
Well, just that, all of your components match up with other components. So like, if you're having a sound, that it would be recognized as being a sound, so if people wanted to customize it, they could do it more easily?
I don't see how, well, the question was, can you use App Inventor to improve your non-App Inventor apps?
Yeah.
One thing you can do is you can link in the App Inventor libraries that have all of our components. We think we have a more beginner-friendly interface to things like the location sensor, to creating sprites that move on the screen. So absolutely, you can link in those libraries. You can get experience with them without having to compile with App Inventor, and then you can take what you've learned and use it in your Java, Android apps. One of you mentioned having developed for iPhone. I can't think of any reason you couldn't create an iPhone backend for App Inventor. It would be a pretty big job, but that would be great if you could create an app and it would run on App Inventor too. The MIT Center for Mobile Learning, which is running an App Inventor, that team includes people shown on the slides. Mitch Resnick from Lego Mindstorm, Star Logo, Scratch, Eric Klopfer from Star Logo, and Hal Abelson are all leading that MIT team. And at Mills, we're doing some work developing components for App Inventor. There's no reason you guys couldn't develop components for it either. Yes?
As far as you know, what's the biggest success story for a program that was designed completely in App Inventor?
Well, the question was, what's the biggest success story for an app completely designed in App Inventor? And I'd say there's a lot of little stories, and that's really what we wanted. So we get email from someone who said his brother is autistic and loves bells, and this person created an app where if you shake the phone, bells ring. Or someone else created something to propose to his girlfriend, who was a Harry Potter fan. And he said that what he downloaded was a quiz, a Harry Potter quiz for winning tickets to the movie opening. But really, when she got to the last screen, instead of asking a trivia question, it said, "Will you marry me?" And then there was an app created by a school kid for information about his school, and that got a lot of media attention. So it's really about a lot of little stories. It's not meant to replace the Android SDK. There are some things you can do in Java that you can't do in App Inventor, but you can create useful and interesting applications. And it's really exciting as a teacher to be able to work with students and say to them, "You've created an app." I bet now 1 in 100 people who runs apps knows how to create one. And you're now, well, this was before 1% had a bad connotation, but to say you're part of that 1% who can do this is really empowering to people. But this is something you can do with your nieces or nephews, or if you go to give a talk in a classroom. Other questions? Yes?
Have you considered making a version of this that runs specifically on tablets? So as a kid, like to me, if you got a tablet for your birthday, you could learn how to make stuff worth dragging and dropping and then hit play and have it run without the computer and everything else. I think that would open it up to a lot more people.
Yeah, so the question was, what about making a tablet version? And that's definitely something that people have thought about and worked on. There's 2 issues. One is making it so you can develop from the tablet, and the other is making it so the apps run on the tablet. And both of those are important areas. If your tablet runs Android, you can run the apps on it now, although since most of our development was for small screens, I can't guarantee it would look good.
thank you very much.
Could you leave with us the information, the code that is related in the scheme, and the translation to
if you download your source code, it has.
I'm just saying.
Let's see. I'm not
when
sure.
you say you download the source code, is the code that Inventor uses the one that comes from the application that you create?
Yeah, now we're changing what you download, so I'm not sure if you still download the scheme, but there's never Java code. There's a compiler that goes from scheme to Java bytecode, which is what comes out of the Java compiler. But you can always download your own App Inventor server and do whatever you want with it, including print the scheme code. But the scheme code is pretty simple. It's just calling the methods in the libraries. Okay.
And the pixels are the same, like in terms of how many they are in the location. So you can look at it and go, because it's so big.
Oh, yes, thank you.
Look at that bounding box, go back to the original part, and then have like a different local algorithm to that area. And I'm just thinking out loud about it. I find it to be a way more intriguing problem than anything else I'm working on. So yeah, keep but yeah, it sounds like there's definitely been some pretty good work done on the processing.
Yeah, no, I don't normally actually use computer at all. I use it in the
Oh, yeah, it just. But yeah, I figured I looked at a lot of stuff, and there were like these really crummy sort of abstracts about how to do it. There's like no information that is valuable, but that one actually had some. I think it actually shows some equations.
Super popular and everybody loves those. They go through transforming really bad transformation. People stop liking
doing, Nate?
How you doing?
Pretty good.
Football one?
Probably not. I got ready for spring break. Got packed. So, how was it last week?
I didn't go.
Yeah.
I haven't been there in a couple weeks.
Jeez. Well, plenty of nice weather the next couple of months. Yeah.
items. One is I did post to Moodle the practice exams for the next exam. There are 3 different documents. 2 are exam type questions, just like the first exam. And then a third document is sort of the themes to focus on. I think there are 7 or 8 to focus on how you study for the exam. I do think we'll do the exam on the 10th rather than the 5th, just to give one extra session to cover all of Chapter 11. And the exam will cover through Chapter 11, which is a little different than the syllabus. So we're going to finish up Chapter 10 today, and then spend a little time, if we get into Chapter 11, maybe not, but that'll set us up for Chapter 11. So where we left off was the topic of discussion was the Phillips Curve, and I think probably people have had some exposure to the Phillips Curve in macro, either an intermediate macro or an introductory course. We have both short-term and long-term Phillips curves, which wasn't always true. So, just do unemployment. Spend a lot of time on unemployment. The annotation that the text uses is U as unemployment rate. And then is the natural